to do the maintenance on it, and they come down once a month. And what we do is the Seabull deep water baths board down at Lady Bay. So these two bores, we drilled it around about the same time. We used the information that was from the Seabull bore to work out what we needed for our treatment plant here before we drilled our bore. And we drilled this bore down to around about 900 metres, and we extract water out of it at about 700 metres because we needed to look at where was the best point to draw the water, so what soils and sediments were around the actual bore itself, and what would produce the most amount of water. So we tried to find a sandy section, and then you put in a screen that's in there, and all the water gets drawn toward the screen, and the sand gets separated on the screen and the water gets pumped up through the bore. So the water coming out of this bore at the moment is 42 degrees, and that's 30 degrees obviously higher than the water we would get from Wanna Water, their town supply. One of the things about this water supply is it's actually a 10th saltier seawater, which is about 10 times saltier than the water that we'd get from the normal town supply. So we need to look at how do you take that water and clean it up a little bit, because if we were to use that water directly in our factory at hot temperatures, we'd get what we call scale inside of all our pipes. It's where you get calcium deposits from what's weathered off rocks. So as the water goes down, this water, we had it aged, and it's actually 50,000 years old, the water that we're drawing out of the bore at the moment. As it goes down through the ground, it wears out the rocks, and it picks up different minerals off those rocks, and it keeps it in the water. When you bring it up to the surface and then you heat it up, those minerals stick to the inside of pipes, and they stick to the inside of different plates and boilers and things like that. So every time you add a millimetre, you reduce the efficiency of all your boiler systems. So what we had to do was size correctly a reverse osmosis plant. So you would have studied osmosis before in biology probably. So essentially what this does is it works the opposite. It uses high pressure to force the water molecules through a very small membrane, and the salt molecules are rejected, so they can't actually fit through. And then the salt stream separated off and the clean stream separated off into a different area, and we use the clean stream for all of our what we call potable water usage on site. So any water